everyone, in this video we are going to discuss a very smart and efficient algorithm which is also known as sliding window algorithm. This is especially used when you have questions which involve continuous arrays, sub-arrays, those kind of scenarios. So let us take a small example here. For example, you are given a small array here which has 3, 3, 6, 8 elements, and you have to find the a sub array of length, let's say 3, okay, which has the maximum sum. So what is the question? Find the maximum sub array of length 3 which has maximum sum, something like that, right? So find the sub array of length 3 with maximum sum. Suppose you have to find this particular question. Now let's first of all start discuss how you will do using a traditional let's say traditional for loop way, like how we do that, right? So what we do, we actually iterate through each of the we decide a starting element, okay, and we decide an ending element, and we keep on extending j, like for example, first of all this will be my first subarray, like first this will be the subarray, then this, right? I will keep on extending, then I will start with this point, then I will keep on extending, something like this. So I'll be printing all the sub arrays which are present in the in this particular in array, and then I will take sum for each, and once I have done that, then I will check whichever subarray has the least sum, for example. So let's try to see what is the problem in that approach. So let us say we have this particular array present and I want to generate all the possible subarrays, right? The traditional method that we use is we define a starting point and we define an end point. So first of all, let us say n is equal to length of array, and then we'll define let's say for we will use a blank subarray which is a blank list, right? We will store all the subarrays in this particular list. So first of all, we will iterate start point. Okay, so how to iterate the start point? We will do for start in range of n. Okay, this is my start, and then I will iterate over my second end point. So the end point will be for end in range, and it will start with start and it will go till end, right? So this is my second point. So I iterate end point. Okay, this is my second point. Now what I have to do, simply sub array dot append, and what will I be appending? I will be appending array of start to end plus 1. Okay, this is something I will be appending. Now once this is done, I will print my subarray. So let's see how many subarrays come for this particular array. So do you see we have printed all the subarrays which were present. So this is first. So this is first time complexity, that n, right? So we needed and on time complexity to print all the subarrays. The second part will be that we will be iterating through each of the list in this each of the sublist and list and calculate sum, and then we will maybe store somewhere, and then we will try to get that, right? So what is the problem here is that first I have iterated over all elements, then I have to again iterate over each element to calculate the sum, right? Because for example, how do you calculate the sum for this? You will calculate for, let's say, array in subarray, okay, and then you will store you will calculate sum, right? And you will store it somewhere, and then you will check whichever sum comes maximum. I'm not going into that part, we have done that coding, but the main part that I'm showing is that you will be doing first of all n steps to create, so n steps to create the subarray, okay, and after that you will need k steps, for example, because you will be iterating over each element again and again, right? So further element, so for example, if there are k subarrays, you will be iterating k times, right? So k subarrays, so k times you will iterate over each subarray. So what does the time complexity becomes? Time complexity becomes O of n into k here, right? So that is the biggest problem. Generally, the number of sub-arrays of a particular length k are given by n minus k plus 1. I will show you with this example. So the time complexity overall becomes n square, right, which is an inefficient method because we are using, first of all, we are looping through each of the list to generate the subarray, and then we are again looping to print the sum. So this basically increases the time complexity, but this is an inefficient technique. What we will do, we will use a sliding window concept to understand how all subarrays are generated, how without generating all subarrays you can still calculate the maximum sum. So what shall we do to avoid iterating over elements again and again and still generate the subarray with the maximum sum? Here comes the concept of sliding window. So it has two types. First is fixed window and another is variable window. So I'll be discussing both type of problem in this video. First, let us discuss the fixed window question, where it was given that you have to return the maximum sum of an array of size k, right? So for example, let us say k is 3. So what you need to do, you need to print all the subarrays whose size is 3, and you need to check which subarray has maximum sum in it. Okay, so how we actually do here is that first of all we define a window of 3 elements starting from the start. So what will be happening here, so because we are starting from here, this will be my starting point and this will be my first window of 3 elements. Okay, so I will create this. So let's say this is my window 1. Okay, so this is my initial window. Now what I will do, for the window 1, I will calculate the sum. What is the sum? 5 plus 1, 6 plus 2, 8. Sum is 8. Okay, now I will slide this window to the right. So what is happening, that now my window will shift, and instead of this window will shift little bit. So now my window will become, it will start from 1 and it will go till 0. Okay, now this is my new window. So what is happening, I am sliding this window. Earlier this window was still here, now it is still here. So what is the window sum in window 2? 5 plus 1, 6 plus 0, that is 6, right? Now similarly you will keep on iterating till you reach the end point. So for window 3 you will have this particular will be your window 3. So what will be the window 3 sum? 5 minus 4, which is equal to 5 minus 1, that is equal to 4. For window 4, what will be your range? It will be this thing, right? So window 4 sum will be equal to 0 minus 5. Okay, then this will be your window 5. If you clearly see that now it will start from here. 5 minus 4, 1, 1 minus 1, that is 0. So window 5 will sum to be 0. And what will your window 6 sum to be? Window 6 will sum to be this one. So 5 minus 4, 1 plus 1, 1 plus 3, that is 4. So if you see, we have just iterated on time. In on time complexity, I am able to generate all the sums, right? And I just need to calculate which is the maximum of this sum. So I will store that and the maximum sum will come out to be this. So the window with the maximum sum of length 3 is this particular window. So this is a basic implementation of a sliding window of fixed size, because here the size of window was fixed. It was not given to me that generate any subarray with the maximum sum. You were given that the maximum length could be n. So let us try to see a visual implementation of this particular algorithm. So this is a array in front of you of 20 elements, right? There are a lot of elements. Now you are given that you have to find array of length 3 with the maximum sum. So start focusing on here and we will see all the outputs here. So let me play this, right? Once I play this, see what will happen. Now each window of 3 is iterating from start to end, and the sum have started populating for each of the window, right? And eventually once it is finished, you see that the maximum sum was 11. So you have a log tracer here and you can track all the sum which appeared here. So 580. So right, let me play it once again. So see, it will start from here and the window of 3 will keep on moving till it moves till the end, and it generates all the sum which are present, and then it will simply take the maximum of sum that has been covered so far. So this is the concept of sliding window. Now, as I mentioned, there can be various versions of it where you say that, okay, I don't want a window of fixed size 3, I want to vary it. So we will try to cover that particular question as well in this particular video, but this is a simple implementation. Now we will move towards the coding part and see how you can implement this directly in the code. So let us start the implementation of this question, that we are given an array and we are given a size of window. For example, let's say k is equal to 3. We have to return the subarray of length k with the maximum sum, right? So like, which is the maximum sum, we have to return that. So we will be using sliding window for this. Now remember, what is the first step? So let's first of all write down all the steps. The step 1 is to create initial window, right? So what will be the initial window? Initial window will start from my first point, right? So initial window will be starting from here and it will go till this particular point. For example, here k is equal to 3, right? So my initial window, let's say this is array equal to this, it will start with array, okay, and it will go from, if you technically see, 0, right, to k, right? This is my initial window. Okay, so 0, 1, 2, and the size of the length is basically 3. So I will set up this. Now what is going to, so I will be storing the sum of this particular window somewhere. So what I will do, I will create an initial sum, just like we do in the maximum sum problem. This is an identical problem. So sum I will take of the initial array. So let's say array 1, I have taken the sum. Now what is happening? Just try to see what is the change happening. Whenever I am moving this window from here to here, I have, from this sum, what I need to do, I need to subtract the previous element, right? And I need to add the new element, correct? So whenever I am sliding any window, I will delete from that particular sum. So I'll do sum which was equal to a1 minus, I will do, for example, array of 0, and then I have to add array of next, which is the coming 0, 1, 2, 3, right? So this is what is happening, right? Similarly, when I move the array size array from here to here, I'll delete the previous element and I will add the next element, and I will keep on storing this particular sum, and then I will see whichever sum is maximum. So let's try to implement this first of all. So the first is create initial window, okay, step 1, and step 2 will be to create the, step 2 will be equal to take the initial sum, okay. So now step 3 will be when you move, so from the sum, subtract the first element, okay, element, and add the next element. That's what we are going to do. And the step 4, that now we have a new sum, so I will compare, step 4 will be compare previous sum and new sum, right? So whichever sum is more, you will store that as maximum sum, right? So initially I'll be taking an initial sum which is maximum. I'll assume that this is, let's say this is the maximum sum, and as I move forward, I will keep on comparing with the next sum of next array, and I will see whichever sum is highest, I will shift maximum to that. That's what we have been doing like in the previous sum questions as well. So let's start implementing this. So what is going to happen, initially I will create an initial window. So the first window will go from 0 to k, because 0, 1, 2. So let's say I have to go till k elements. So 0, 1, 2 up to k. So I have to take 0 to k. So the initial window sum, so the maximum sum, or what we were saying, that that will be called as initial sum. So let's calculate initial sum, okay. So what is that? Window, let's call it window underscore sum is equal to sum of array, okay, and this array will start from 0 and it will go till k, okay. So it will start from 0 and go till k, and now I will set this window, because right now I'm at the start. I will say let's say max underscore sum is equal to this particular window underscore sum. Okay, so I have set my initial pointers. This is my window sum variable which will be varying, and this is my max sum. Right now it is set to be window sum, and I will keep on varying as I move forward. So now I will create the sliding window. Slide the window from left to right. This is what we will be doing. So now how to go from that? So I'll create a loop that for I in range, and now see where till what point my I will vary. Because let us say if I'm saying that my window is of length 3, so my I pointer, the initial pointer, it will start from here, okay, and it will go till here only, correct? So that is what you need to do. You cannot go beyond that because you need a window of 3, so you cannot step I beyond that. So the I will start from 0, okay, and if you clearly see, it will go from length of array, that is n minus k, right? For example, let us say when the length of window is 2, so so in this particular 1 2 3 4 5 6 7 8, so my length of array is 8, okay, and till what point my initial pointer will go? It will go from 0 1 2 3 4 5 6. It is going till 6, and k's value is 2, correct? Now suppose my element was 3, so it will go till this particular point. So it will become 5 in case of k equal to 3. So if you clearly see the pattern, it is n minus k. So 8 is n, and minus k is the initial pointer till where it is going. So let's start moving this. For I will move from 0, and it will go till range. So 0 to length of, you can say, array minus k. Okay, again this 0 is optional. You can remove this as well. It's totally up to you. So now what I have to do, I have to create. Now see, whenever I am in a window, right? So what will be my new window? I have set an initial window, right? So I have to update this window underscore sum. Okay, now let's try to focus a little bit here, that how things are varying. So if you see that my initial window is this, right? Now when I am starting, I've just by default set up. I have not even started the iteration. So now my I is equal to 0, correct? Now when I will move from here to next element, like when I'm moving from here to here, what is happening? I have to remove my previous sum. So from my current sum, I have to subtract array of previous, that is 0. And what I have to do? Add array of 0 1 0 1 2 3, right? So this is what is going to happen. Now if I have to try to visualize it in terms of I and k, so what am I actually doing? See, this is my I, where I is starting from, correct? I plus 1. Okay, let us say the window is k. So I'm going till this particular point. So I will be going till, let's say, array of I plus k. Now this is I plus k. This was out of it. So my initial window was this only, right? 3. Okay. What I'm doing now, from this sum, I'm now removing array of I, because I'm removing this particular element, right? As I'm moving here. And what I'm doing, I'm adding array of I plus k, right? This is I'm doing. So this will be how I'm looping in, I'm adding in the sum. So I will say window sum will equal to my previous window sum that was present, window underscore sum minus array of I, which I created, plus array of I plus k, right? So I removed the previous element and I added the next element. Now what I have to do, if you see, I have to compare previous sum and the new sum. So what I will do, I will say that max sum which I have stored here, now it needs to be maximum of, okay, maximum of window sum and max sum which was already present, which we already calculated. Okay, so this way it will check, okay, whichever sum is highest. So if this sum is highest, it will stick to this, otherwise it will move to next, and that's how it will keep on looping and it will remain the maximum. So for example, let us say if there were for the window 1, okay, for window 1 sum is equal to 5 plus 2 7 plus 1 equal to 8. Okay, and so what is the maximum sum till window 1, which is equal to 8. For window 2 sum is equal to 5 plus 1 6 plus 0, that is 6. So what now you'll see, you'll compare these two, what is the maximum in this. So the maximum still remains 8. Now window 3, so 5 minus sum is equal to 4. So what is the maximum between 8 and 4? It will remain to be 8. Window 4, which is equal to, so 0, it will become minus 5. So again sum will remain minus 5. Window 5, sum will become, so minus 1 minus 1 0. So sum is equal to again 8. And what is window 6? Sum is equal to 8 minus 4. So 4 versus 8, it will still remain to be 8. So that's how this comparison is happening. Every time you are creating a sum and you are comparing, whichever is the maximum, you are storing that particular thing. So now this is your maximum sum, and I think yes, this is done. So I will just simply check if everything is done. Yes, so now max sum will give me the array of maximum sum. So let's see if it is giving us that. So I will simply go print max underscore sum. So what it should come out to be, it should come out to be 5 plus 2 7 plus 1 8. Ideally it should come out to be 8. Let us say what it comes. See, it has come to be 8. Okay, so that's how we have done in just O(n) time complexity, because we have just iterated over the list or array once, right? And we don't need to like do multiple loops, multiple iterations, and we are able to generate. So this is called the sliding window algorithm of a constant window, where the window is constant, and that's how you can generate sum. You can compare subarrays and see, like you can do maximum sum, minimum sum, like there are a lot of variations of this. I will give the assignment, you can try solving that. But this is how the architecture of a sliding window algorithm. So I hope it is clear. Now let us move to the next part. So let us now discuss the second version of this sliding window algorithm, where the window is dynamic, where the length of the window, for example, in the previous case was fixed to be k, but here the window can change. Right? So the question here is, you have to find the smallest subarray with sum greater than equal to s. So for example, let us say value of s is equal to 7. So they want us to find that minimum subarray whose sum is at least 7, right? Now one method, as we know, is that you can take all the subarrays, calculate the minimum, and see whichever the subarray is that, right? So that method is by default the brute force approach. You can do that. But in this right now I'm going to discuss the sliding window, because this is a dynamic sliding window question. Okay, where your sliding window's length will, you will see it will expand and it will contract as we move throughout the question. Okay, so let us start building approach. Let us start understand the architecture for this particular. So what we will do, that first of all we will set up my just like previous question, I will say that, okay, let's say my initial sum is equal to 0. Okay, I have not started yet, and this is my initial pointer. I will start from here. So what will happen, that when so let's say this is, I'm starting with I equal to 0 here. Now when I am starting with I equal to 0, so remember there will be two steps happening: expansion and contraction. So either we will increase the window or we will reduce the window, but we have to keep in mind that our sum should be greater than equal to 7. So our step 1 is to, starting from the I equal to 0, get that window which has sum equal to greater than equal to 7. So how we are going to do that? We are simply going to start with I equal to 0 here, and we will keep on adding elements till we reach sum equal greater than equal to 7, right? So my initial sum, let's say, is 0. Now what will I do? I will, so this is my initial window. Now it will expand, right? It will go till here. So my sum will become, sorry, initial was sum 0, then at I equal to 0 sum was equal to 2. Then when I moved I equal to 1, my sum become equal to 5. It is still not 7, right? Then again when I moved here, my sum will become equal to 3 to 5, 5 plus 1 6. It is still not greater than equal to 7. But once I move here, right, so my sum becomes equal to 8, which is greater than equal to 7, right? So my initial window, if you see, is 0. So I is from 0 to, so 0 1 2 3, right, 2 3. So total length is equal to 4. So I have found my first array which has sum at least greater than equal to 7. So I will store the length of this particular sub array, because this is my first sub array whose sum is greater than equal to 7, right? So what I will do, I will store this length. So I will create a let's say minimum length somewhere, and right now the minimum value is 4. Okay, now see what is going to happen, that remember I have to get the smallest subarray. So what I have to do, I have to uh, check, is there any subarray whose length is less than 4 and it still gives me sum greater than equal to 7. Now think, just by keeping the window stuck here, if I increase the length, it will not give me the minimum subarray, right? So what I have to do, I have to contract this subarray. So what I'll be doing, that keeping the endpoint same, okay, what I will do, I will reduce my window from the left side. So instead of this, my new window will come out to be till here, right? So now this is my new window. So I will shrink, basically I am shrinking. So once I have reached an array which has given me the sum, target sum, I will shrink my window from the left. Okay, so now what is my new sum? If I see what is my sum coming now, let's see. So my right now my sum is 3 plus 1 4, 4 plus 2 6, sum is equal to 6. Now this sum is not greater than equal to 7. So what do I need to do? Now I need to expand. Okay, so what I will do, I will, from here I will expand my window. So it will go from here to here. Now this will become my new window. So what is the sum here? So this sum is equal to 3 plus 1 4 plus 2 6 plus 4 10. So this array is giving me that particular array which has sum greater than equal to 7. But if I check the length of this particular sliding window, it is still 4. Now my minimum was already 4. I need something which is less than 4. So I will not be updating my minimum length of subarray, right? Because I want a subarray with at least the sum of 7. So now what is going to happen? Remember, now again we are going to shrink from the left side. So shrinking will happen. So this will come here, and now this will become my new window. Okay, now let's check what is the sum of this window. 4 plus 2 6 plus 1 7, and surprisingly we see that even after reducing an element from the left end, this is a very important point, even after removing or deleting the element from the left side, I see that my sum is still greater than equal to 7, right? The sum is 7. So what is my length? So this particular array is acceptable. Now what is the length of this particular array? It is 3. Now I see that this length is less than 4. So I will update my minimum length from 4 to 3. So far till this particular point, I have seen that the minimum sub array with sum greater than equal to 7 has length of 3. Okay, now let's move forward, because we have still elements left. Let's try to explore, can I improve even result even to this? Can I get something even less than this? So what will I do? I will further shrink it, right? Now if I further shrink it, I see that sum become equal to 6. Now so further shrinking has not helped me, because now sum is not greater than equal to 6. So now the length is 2, but the sum is 6. So what I need to do, I again need to expand it. Okay, so now what will happen? This happened, and I will increase the window size from this to this. Okay, Now what do I see? My sum is equal to 4 plus 3 7 plus 2 9. Now this array is acceptable, but length is again 3. Now my minimum length is already 3, so this has not actually improved the result, right? So now what I will do, I will shrink. Okay, now for shrinking I will reduce from here. Okay, and now my window will become like this. Now if I see this, the sum is equal to 7 and it matches this condition, and the new length of this particular array is 2, and which is better than my previous minimum. So what do I see? That I have improved the result, and by the time I reach the end of the window, I got an array with length 2 whose sum is greater than equal to 7. So this is how the magic of, I will say, dynamic window size, where dynamic sliding window, where your window size keeps on varying, and as its size keeps on varying, you see the change in results, and you can eventually reach whatever you're looking for. So first time when you're solving this, it might sound a little complicated, but don't worry, I'm going to explain this explanation once again so that it fits in your mind. So let us now discuss this once again, the approach, so that it actually fits in your mind. Now what is my target? I need to get those sub arrays whose sum is at least 7, right? And I need to find the smallest of them. So what I will do initially, I will start from here. This is my first subarray, right? So if I see my initial sum is equal to 2. Now I have not reached, so if I see, remember, we'll be doing addition. So we will be doing expansion when we see that my sum of this present subarray is less than the target, and I will do contraction when I see that, okay, now I have reached to a subarray whose sum is greater than equal to s. Now can I contract it so that I can get a smaller subarray? So this is the target. So first of all, we will look, the step 1 if I have to do is to look for this first subarray who meets this criteria. And if we see that, so the first subarray, this is not the case, so we will expand it. It is still not the case, so we will still expand it. Now we will still expand it. So at this particular point, you see that 3 2 5 6 7 8. So this subarray initially is your first subarray whose sum is greater than equal to 7. So what you will do, you will highlight this one. Now remember, once you reach to a target, and what you will do, you will store its length somewhere. So let's say my minimum length, so my minimum length so far is equal to 4. Now what do I need to do is, now I need to look in this subarray, can I reduce the length so that I still meet the criteria? Now remember, the array has to be continuous. So either I can add element here, or I can add element here, or remove element from here, right? So what I will do, I will remove the element from the left, because to the right I have already added. Now once I do this, so what result comes in? We see that my new sum is 3 plus 2 5 plus 1 6. My sum is equal to 6, which is less than equal to my target. So now this array subarray is not acceptable. So what I will do, now I will expand. So this is gone. Now I will expand this. Now this is expanded. Okay, now this sum 4 plus 2 6 plus 3 9. So this sum is equal to 10, which is greater than equal to target. Yes, so this array is acceptable, but again its length is 4. So now even though this array is acceptable, I cannot actually take it, because the length, it is not improving my overall result, right? So now I have to see, can I reduce the length from here and still reach the target? So what I will do, I will reduce the array size, the subarray size from here, and I will see. Now this is my new subarray. The sum of this particular subarray is 4 plus 2 6 plus 1 7. Yes, so sum is 7, which is greater than equal to target. So yes, this subarray is acceptable. I will update my length from 4 to 3. Okay, so my new length is equal to 3. Now I have to see, even if I reduce further, let's say I contract it further, do I see any improvement? No, because what will happen, once I contract, my sum becomes equal to 6, right? My sum becomes equal to 6, which is less than equal to target. Now this is not acceptable. So what I will do, I will further increase the window size. Okay, so I will increase it. 4 plus 3 7 plus 2 9. Now sum becomes equal to 9, which is greater than equal to target. But again, the length is 3 only, so it is not improving my result. So I will not take that. So now I will again shrink it to see if there is anything less than this possible. So let's do this, and we see that we have reached to a subarray of size 2 whose sum is greater than equal to 7, right? And that's how we will do. We will update the value of our length here, and this is my final answer. So this is called a dynamic subarray of sliding window, where you are given some questions. So there are a lot of dynamic, this type of questions are very intuitive. You really need to think before you actually start coding. So now we will move to the coding implementation of this particular algorithm. So let us start the coding implementation of this question. First of all, let us discuss the architecture. So the architecture says that the step 1 should be to create an initial window which is sum is equal to 0. So let's say initial window with sum equal to 0, and I have to set an initial minimum sum, right? So let's say minimum sum is equal to infinity, because remember, whenever you have to find a minimum sum, we take the minimum sum as infinity, and when we have to find the maximum sum, we take the initial sum to be 0. That's how we initialize, right? So now, so first of all, we will do that. Now my target 1 is to get the first subarray that meets the condition of sum greater than equal to 7. So first I will code till this particular point, right? Now how to get this point? What we will be doing is we will be starting from, so one will be my start point, okay, and another will be my end point, right? So let's say this is my start point, and my end point will first start from here, then it will go here, then it will go till here, till it sees the subarray which satisfies the condition. So I have a 2 pointer here technically. So one is I or j, you can assume that, or you can say start or end. So we will start with, so first of all, let's write down the program def, let's say smallest subarray. Okay, so I'm taking an array and taking a value of s in it, and I have to return what is the smallest subarray, for example, right? So how to do this? Let's set up n is equal to length of ar. Okay, now this is the first part. So I will do start is equal to 0, because I'm starting with initial. My starting point is starting from here. So initial point will be initialized at this particular point, and then my initial window sum, let's set up equal to be 0. Okay, right now I have not created any window. I will start it. Okay, now this is the point. Now I have to set a minimum length. So I will do minimum length, which is equal to float of infinity, I can say that, or you can pick a very large number, for example. So you will do float and you will do I infinity. Okay, so this is your minimum length. Now you will vary your endpoint. Okay, so for end in range, now what will be happening, that I will go towards all the elements, like which, so first this array, then this array, right? I have to explore all till I reach the arrays which satisfy the particular condition, where sum, which start from this particular point, right? I have to, which start from this particular point and which satisfy the sum greater than equal to s. So what I will do for end in the range of n, okay, this is my endpoint. So I will keep on adding window underscore sum, which I created here. So let's say, let's call it window sum. Window underscore sum is plus equal to, it's plus equal to what I will do, array of end. So what does this line mean here? This line means that initially I have set my sum to be 0, right? So my start point is here and my initial sum is, let's say, 0. Now I'm varying. So my end point, first of all, end will start from here, right? So my initial sum will become equal to 2. Then it will move till here. So sum will become equal to 5, then 6, then 8, then 8 plus 4, 12, then 15, right? It will move this way. Okay. So what I'm doing, I'm adding sum as I'm like increasing the window size. So right now, this is the scenario. Okay, so after this, what we have to do, remember, we have to get that particular window which satisfies my condition, right? So what I will be doing is that I'll using a while loop, that while, if you check, window underscore sum is greater than equal to your s, right? What is s? The value that is given, because I cannot take all the arrays. Remember, I cannot take everything. I need those things where sum is greater than equal to 7. So I'll put while window sum is greater than equal to s. Okay, now let's say it found all the, it will find multiple, right? It will, first of all, it will find this array, then it will find this array, right? I have to get the array with the minimum length. So which is the array with the minimum length? It is the one which is found earlier, right? So out of these three, I'll pick the first one. So how we are doing that? I will do that minimum underscore length. I will update it. Okay. Now this has to be equal to minimum of what? Of already minimum length, which was there, minimum length. Okay. And after that, remember what is the size of any window? So this is the start point. Let's say start index. This is the end index. So if you see it, let's say any window starting from index 1 and it is so let's say this is 1, 2, 3, 4, 5 and this is 0. So what is the length of this particular window? It is end point minus start point plus 1, right? What is that? This is 5 minus 3, 2 plus 1. So 5 minus 3 plus 1. Okay, this is equal to 3. This is the window size. So what is the window size of any array? It is end point, end index minus the start index plus 1. So I have to take the minimum length to be equal to end minus start plus 1. Okay, this is the problem. Now I have found the minimum length. So in the first scenario, I have found that, okay, this is my minimum length. Now what do I need to do? If you remember, so my first task is completed, getting that particular array whose sum is greater than equal to 7 and it has the least elements. So I have found the first array as of now, which was this one. Now what I need to do, I need to shrink element. I need to shrink it from the left side and check if I can further, because my array is starting from here. So now I need to shift my starting point from 0 to 1. So I will be increasing my left pointer by one pointer. So what I have to do here, shrink. So shrink the window from left. That's what I need to do. So what I will do now, whenever I'm shrinking, what is happening? My sum will reduce, right? Because now I'm shrinking the window size from here to here. Now because I'm shrinking this particular, I'm splitting this particular part. So my sum is reducing by the element which was present here. Okay. So I will first of all update my window sum. So my window sum now will become equal to, so my window sum will now become equal to window underscore sum minus equal to your array of starting point. Okay, the start of the window, which was here. So it will now, and what I have to do now, I have to increment my start pointer by equal to 1. So that's it, right? That's all. It will keep on happening. It will expand. Now what will happen? Once your start moves from 0 to 1, your loop will start again, because start will get updated, right? And you will once again come in the loop, follow the same process till you reach the element. And that's how this coding is done. Now, eventually what you have to do is that, see, you will do return. Okay, so what you have to return? You have to return minimum length. Okay, minimum underscore length. If minimum underscore length is not equal to infinity, because for what if you do not find any such element, which is, you do not find any sub array which is meeting this criteria. So what you have to do, you do not want to return anything in that case, right? So in those particular scenario, you will return simply 0, that no such value exists. And this is how the coding part of this particular thing is done. So at first, you are, from this point, you are setting up the start the window, and after that you will constantly increase till you find the at this point you will find the first window that satisfies the condition. Okay, after you find the first window, you just need to uh, shrink from the left, and and then again follow the process to see can you again find, because now start will update from 1, so you will again iterate through all the arrays, check which is the minimum sum in this particular area, and that's how you're going to generate the sum. So now let's test it out. What does it give? So I will be calling this particular function subarray, smallest subarray, and I will pass it, let's say, smallest subarray arrs. Okay, so let's see what comes. So I've got 2, right? Because remember 4 and 3 were the 2 elements which were the subarrays with the minimum sum. So this is called the dynamic sliding window, where your window size keeps on changing, right? Try to understand this question intuitively first before coming to the coding. Coding is very simple. First part is still this, then you have to update, and then you have to constantly loop again and again, right? So this is a very important question if you have to learn dynamics, like sliding window. If you can solve with this method, this really gives interviewer a very good confidence that yeah, this person is very proficient with Python coding and the logic building. So I hope you understood. We did both the static window and we did the dynamic window. So now there will be an assignment. Please try to solve them. I have included a lot of questions on sliding window in the top 50 question that I've shared. Try to solve them using this particular approach. There are a lot of good questions in sliding window, where you still need to think a lot, because again, this is just an approach. Okay, there's no mandate that you have to solve using this, but using this method you can really get amazing results of solving the questions. So thanks again for watching this video. I will see you in the next video. Till then, keep enjoy and start learning. So thanks again. Thanks for watching this video.